Hi everyone, this is a Math 082 video on 3.2, the zero power rule and negative exponents. So the first thing I want to do is I want to think about order of operations. So my first order of operations is parentheses. So what I need to do is I need to look inside my parentheses and see if there's anything that can be simplified. So I have a 2 and a 3, those are constants, but they can't be reduced or simplified because 2 and 3 don't have any common factors. Okay, over here I have 3 to the third and 2 squared, but again, there's no common factors. Over here I have x to the 6th, but I do not appear to have any other x's, so nothing can be done with that at present. And then over here I have x to the negative 6th, again, no other x's, so I have to leave that alone. Over here I have a y, but no other y's, so nothing much can be done. And over here I have y to the 8th power, but no other y's. The one thing that I can do is I have m to the 0 power, and we kind of have to assume here that m is not equal to 0. If m is any value other than 0, we know that anything raised to the 0 power is 1. So that's one thing that we can eliminate from our process. Okay. So at this point, we have successfully not evaluated, but sort of resolved anything inside the parentheses. So now we're going to move on to our exponents. As you can see here, there's this 5 up here, which means that every single term in these parentheses is going to be raised to the 5th power, the constants as well as the variables. So let's go ahead and do that. So I'm going to have 2 to the 5th power times x to the 6th power raised to the 5th power. Then I'm going to have 3 to the 5th power times y to the 5th power. Okay? I think I mentioned in previous videos, it's generally advised that even though it takes a little extra time, you write out the whole equation every time, just so that you don't forget that it's there. So let's simplify some of these things. The only thing over here that really needs to get simplified is this guy right here, which is x to the 5th raised to the 5th power. Okay, so 6 times 5 is 30. That's using the power rule there. Now at this point, I'd like to point out that many students would be inclined, since we have, for example, 2 to the 5th power, 3 to the 3rd power, students would be inclined to evaluate that using a calculator. And I am going to suggest that you hold off on evaluating these numbers until the very end. And in a minute, hopefully you will see why that is advantageous to us. Okay? So at this point, if you wanted to, you could actually connect this and make it a single division problem. Okay? And then, if you recall, the thing that I always have people do, and that I always do when I'm doing these problems, is that I like to rearrange things. Okay? Because multiplication, remember, is commutative. So I'm looking at all these numbers, and I want to rearrange them so that they're actually right next to each other. Okay? So let's do this. We have 2 to the 5th power times 3 to the 3rd power times x to the 30th times y to the 8th. Okay, that's what we have in our numerator. Downstairs, again, I'm going to try to put them so that they're right above and below each other, the same bases. We have 2 squared times 3 to the 5th times x to the negative 6th times y to the 5th. Okay? Hopefully, visually, you can see the advantage of doing this, because now I can use the, I don't know why I did that. I can use the quotient rule here, and I can use the quotient rule here. I can use the quotient rule here. And finally, I can use the quotient rule over here. So I'm going to use the quotient rule 4 different times. Remember, the quotient rule says, for example, if I have 2 to the 5th divided by 2 squared, it tells me to subtract those exponents. So in this case, 5 minus 2 would be 3. So let's work through this and subtract our exponents. So this is going to give me 3. Over here, 3 minus 5 gives me an exponent of negative 2. Okay, let's look at 30 and negative 6. So this is actually going to be 30 minus negative 6. Those are my exponents. Minus a negative, remember, gives me plus a positive. So this actually becomes x to the 36th power. Okay, so again, it's really a great idea to write out your exponents like this when you have negative signs mixed up in there and you're using the quotient rule. Because otherwise it's so easy to think, oh, 30, negative 6, and subtract, when in fact, as you can see, we didn't need to subtract, we needed to add because we're subtracting a negative. Okay, so be careful, the signs are tricky. All right, then we have 8 minus 5, which is 3. All right, we're almost done. We're very close to being done. What we need to do, 2 things, right? If we're putting this into My Open Math, then we need to evaluate our numbers. And then the other thing that we need to do is get everything in terms of positive exponents. So I'm going to have to go to a new page here. So, didn't really mean to copy this thing, but that's okay. So let's deal with our negative exponents first. The only negative exponent I see is this guy right here. Okay, oops. So remember, with negative exponents, they move, right? If they're upstairs, they move downstairs. If they're already downstairs, then they move upstairs. Okay, and then as we move them, the exponent changes sign. Okay, so we have this expression right here. So all that remains to do is to actually evaluate. Ooh, that should be a 6. It doesn't look like a 6. We're going to evaluate our value. So 2 cubed is 8. 2 times 2 times 2 is 8. 3 squared is 9. So that should be right there your final answer.